Okay, this is Vertex of a Parabola Part 2, and what we're going to do is try and graph something that looks pretty ugly. It's got lots of fractions and some negatives, but you know what? This is going to be made pretty easy because we have our vertex formula. So I'm going to just first of all identify what is A, what is B, and what is C. And then I'm going to plug them into this formula here, which gives us the vertex. I'm just going to write it over here. That formula is negative b over 2a. And then this part, remember, there was two components to it. It was c minus b squared over 4a. So that's this little vertex formula. And once we've identified a, b, and c, we're in business. So A is negative 1/2, B is 3, and C is 7/2. Okay, so I'm going to go ahead and plug those in and try to work out where that vertex is. So let's get started. We've got negative B, so that's negative 3, all over 2 times A. So that's 2 times negative 1/2. Okay, so that's the x component. And for the y component, we've got c, which is 7/2, and minus b squared, so that's 3 squared, and all over 4 times a, and a is negative 1/2. Okay, so all I have to do now is kind of work out where these exactly are. So we've got, it looks like negative 3, and 2 times negative 1/2 is negative 1. So if this is negative 1, and you got negative 3 over negative 1, then that's just at good old positive 3. Over on this side, I think I got a little bit more to figure out here. We've got 7/2, and then we've got minus. Now this would be 9 on the top, and 4 times negative 1/2 is negative 2. So what I'm going to do, I'm going to take this negative and tuck it in with this negative and turn that into a plus. So this is 9 over 2. So that worked out quite well because 7/2 plus 9/2 is 16/2, and 16/2 is just 8. So here's our vertex. So even though it looked really pretty miserable, there's the vertex. Now, before I pull the grid up, there's one more thing to make life really easy for ourselves, and that is to get one so easy to grab point, and that is the y-intercept. And the y-intercept occurs when x is 0. The x-intercepts are sometimes a lot of work to get, but the y-intercept is no problem, because if you go back to your original function, if you put a 0 in where the x is, then this first term becomes 0 plus 3 times 0. So both of these first terms, the first and second terms, they become 0. And so we're left with 7/2. Okay, and we might just want to think of that one as a decimal. It's probably a little bit easier to graph. So 7 divided by 2 is 3.5. So there's my y-intercept, there's my vertex, and I know that these graphs are symmetrical. So what more do I need? I think all I'm going to do is clear the page and pull up the grid. All right, so there's the grid, and I'm going to plot my vertex. So 3 and then up 8. So 2, 4, 6, 8. So there's my vertex. And this other point, the y-intercept, was at 0 and up 3.5. Now, because of symmetry, this obviously is the left side of the graph here. What I'm going to do is I'm just going to beam across, and we went from sort of like a little framework. It's like saying, okay, I went from my axis of symmetry, I went 3 units over to get this point. So from my axis of symmetry, I'm going to continue over another 3 units and put kind of the reflection on the right side. And that gives me a little bit better framework here. So now I will attempt to draw a very nice parabola. Let's see how it goes. Okay, so this guy looks like it's going down something like that. And on this side over here, I've got to make sure I get through this point here. Okay, and we're just going to keep going now. All right, something like that. All right, and there's my graph. So that vertex formula can be very helpful, really speeds up the job of producing a picture. And that's where I'm going to stop with this section.